Since it's just five of you guys, we'll just make it kind of interactive. I'm Kevin Lee. I'm with Azul Systems, and if you don't mind, I kind of like to kind of know who you are too. So if you don't mind, just telling me, kind of sharing where you're from, what you do, I think will be helpful. So, hey, if you don't mind.
Hello, my name is Tobias. I'm from Germany. I'm a software developer, and I'm interested in IoT. So.
Great.
Totally interesting.
All right, great. Thank you. Yeah.
Hello, I'm Christian. I'm from Hungary, software developer too, and I am interested in embedded systems, C-based and ARM-based in general. This is why I'm here.
Great. Awesome. Thank you, Christian.
And my name is Jungsboot. I'm also a software developer from Germany, and I'm on the IT security domain.
Okay.
We're also producing machines for devices, so I'm interested.
Okay. Great. Thank you.
Hello, my name is Rainer. First, I'm from Austria. I'm a software developer too, and the company I'm working at, we are developing a software PLC. It's an industrial controller. Software, so more like embedded.
Okay, great. And
hello, my name is Uray from Spain, and I'm a software computing engineer.
okay, great. Thank you. So I gather you guys have done some sort of a development for embedded IoT in one form or the other. Okay. And are you guys using Java by any chance? You guys all using Java? Okay, great. So you guys have played around with the Raspberry Pi or Edison by any chance? Okay, so this will be kind of really straightforward then. Basically, what we're trying to share with you is how you can actually use available open source technology, namely JVM that we provide, that you could actually use as a platform for your embedded development and ultimately for your IoT applications. And what I was going to go through is kind of give you a little introduction of what we do, what we provide, and how you could actually take advantage of what we provide and kind of help you with what you're trying to do with the either embedded or IoT development. And I have some samples that we built around Intel Edison. And actually we have two demos out in the exhibition area by the auditorium that actually showcases how we did it. So we'll focus more on the actual demo because that's probably more interesting. I'll share how we built it. And at the end, I'll give you my contact info so we could I could share some of the sample code that we actually used to build a demo. So you could, try to replicate or do something similar or extend what, you guys want to do with it. Hi, Andre. Hi. Yeah, since we're a small group, I was just going to make it more interactive, and we just sort of do a quick intro to you, if you don't mind, since you're, didn't mean to put you on the spot, but would you want to share who you are?
Okay, I'm Andre. I'm working at Continental Automotive Romania in Java.
Okay.
We are working with AutoSAR at AutoSAR Center.
Okay.
The connection with Java is I'm basically working on writing C code.
Okay.
But also some generators. We write some generators in Java. They generate the C code.
Okay.
Yeah, and basically our tools are based on Eclipse.
Oh, okay. Gotcha. So your tool actually generates a C code?
Yeah. And
From
also
Java?
the configuration tool is based on Eclipse.
Okay.
For that loads the meta model, AutoSAR meta models.
Okay.
Yeah.
That's interesting. Okay, great. So just a little background before I tell you about what we do. A little bit about me. I spent the last 5-6 years at Oracle from Sun Microsystems days. I've been working with our Java on and off about 10 years. I spent a lot of time working with embedded. So I was a product manager for Java 8 embedded. So that's when we actually did the compact profiles. So the main reason why we did compact profile on Java 8 is because we had a lot of legacy customers using Java ME, especially the customers who are using CDC configuration. I don't know if you heard about it, connected device configuration, which is based on Java 1.4. And because Sun unfortunately didn't invest much time to modernize Java, so there's been like 5-6 year gap between Java 6 and 7. I don't know if you recall. So there was some hibernation in Java development. So it was time for us to provide some modern APIs for Java developers as well as some of the customers who are using Java. So we came out with Java 8, but original intent was to provide modularity in Java 8, to make it more useful for smaller devices. Because a lot of the issues with embedded IoT, when you talk about trying to run application on a small device that has very limited resources, is to have a small form factor. So this whole modularity concept would be really beneficial. So we thought initially, okay, let's put modularity in Java 8. But unfortunately, because there's so much complexity involved with the language and all that, modularity had to push out, unfortunately, whether we like it or not. So this whole project Jigsaw, which was the baseline for the modularity, got pushed into Java 9. So in interim, we had to come up with something that would address the embedded need, if you will, to make it smaller than standard Java SE, which is like at least 64 megabit if you include the AW swing and all that. So say, okay, let's do something smaller. So we decided to do with something like compact profile. So hence that came about. So if you look at compact 1 on Java 8, that is sort of a direct sort of replacement for Java ME connected device configuration. So it's got baseline language features, networking I/O. So you could do everything you could have done in old Java ME 1.4 in Java SE with the latest API. So a little bit about what we do. So Azul is based in California, in Sunnyvale. So we've been in business for the last over a dozen years. We start out as a JVM appliance company. So we are one of the 3 or 4 companies that have official TCK license from OpenJDK. So besides Oracle themselves, IBM, Red Hat, we're the only other company that actually has TCK license. That means when we provide a build of JVM, we certify them. So it meets all the Java specifications. So you could be assured that apps you run our JVM meets the Java standard specifications. So unlike other JVMs you might find in the market, you guarantee that you're compliant with the Java standards. So other thing that's interesting is that we do actually have a seat in JCP, Java Community Process. So our CTO actually has a voice in the table. And we do Java, that's all we do. So we have JVM that runs on the back end for the enterprises. So the product we call Zing, which is full-blown Java with the sort of what we call our own jobs collector, GC, that allows consistent response in terms of garbage collection, so that you don't have the stop the world GC pauses. So for those type of GC would be useful for in a case where you're running into a large memory heap in your applications or requiring some predictive response time for your applications. So for example, trading applications that requires predictive response time without being worried about hung up on GC pauses or jitters, right? So major investment banks are running that in their backend. Now, with OpenJDK, what we did is we decided to build a smaller version of JVM, which is based on Java 8 compact, and decide to provide a runtime for embedded devices. So one thing that everyone should know, I think is really important, I don't know if you guys were or not, why do we care about open source Java in the embedded IoT space? Because have you guys ever used Oracle JDK or Oracle Java? Have you ever guys looked into their licensing terms? Well, let me ask you this question. How many of you guys have a Blu-ray player at home?
What is home? Sorry.
Do you have a Blu-ray player at home? Blu-ray disc players at home? You don't? You guys all kind of latest generation, so you guys don't. Okay. Well, anyway, so some of the older people like me who still have yeah, there you go. Blu-ray players, those devices actually are considered commercial embedded devices. So that falls on the licensing term that Oracle calls non-general purpose computing. So that means you have to pay a license fee to Oracle, about $1 per device. Right? So let's say you decide to produce a commercial device, right, that runs Java Embedded, which you've downloaded from Oracle, and you create an application. Let's say you decide to commercialize it, right? Then you're obligated to pay a license fee to Oracle. So if you're a developer, right, you don't want that, right? You want to be able to distribute it freely as much as you can. So that's why open source is supported. So that's what we provide, open source JDK. So without having to worry about, having to pay any type of license royalties, then open source is ready to go. So that's why we built it. So Zulu is our product name for OpenJDK build. Like I said, it's been certified, so you could run all your Java. And the way we make business is through the support. So for those people who are looking to get professional support on your Java platform, then that's where we come in. If you don't need a support, obviously you could do whatever you want to do. But having said that, in terms of what you could actually do with our Java runtime, we have builds available for pretty much all flavors of Linux. If they're not already downloadable, it's something we could build, so you just have to let us know. Latest build we have done is actually with Microsoft Windows 10 IoT Core. So, as you know, Microsoft has released unified Windows platform now, which they supposedly be able to run your applications across all the devices from embedded, enterprise, or desktop. We're the first one to provide a build, OpenJDK based build for Windows 10 IoT. So you could actually develop an application in Java and be able to deploy it on not only Linux, but Windows app as well. And one of the demos that I'll show you guys actually is built on top of the Windows IoT. And just for your information, Microsoft has changed their licensing term for their Windows 10, especially in the IoT space. Usually with Windows CE, you had to actually get a license per device, but Windows 10 actually allow you to freely use and distribute same business model as what the open source guys are doing, similar to ours. You just pay for support if you need support, but you could, in theory, be able to use Windows 10 IoT pretty much anywhere. So besides the Linux window, we also have JVM builds for Mac as well. So this is pretty much a drop-in replacement for Oracle JVM that's out there. Any questions so far, guys? All good? Okay. So Zulu Embedded, so again, same code base, OpenJDK. We built it for embedded. We have a 32-bit as well as 64 bits that's out there. And for some of you who are requiring some specific OS distro builds, we may be able to help you guys out there too. Let's say if you have some, Linux OS that are not, sort of standard, let us know. We may be able to build one for you guys. Right now, it's available for 6, 7, and 8. Obviously, we're also planning to do early access build of Java 9. We already have access to the code, which we would be releasing relatively soon, so we would be providing early access for Java 9 as well. And believe it or not, there are devices more than 2 million out there that are already running our JVM in the embedded devices. So it's been proven. So running on actual embedded devices. So the demos we built, we used Intel Edison boards. Have you guys actually tried out Edison? Any of you? Nothing? No? Raspberry Pis? All of you Raspberry Pi? Okay. So we'll actually have a Raspberry Pi version of our JVM in a few months. We're actually actively working on a build for ARM v7. So probably early next calendar year, we'll be providing a download for anyone to come and download and install on a Raspberry Pi or ARM v7, any board that runs ARM processor. For example, cases we actually build our demos on Intel Edison. But in essence, your Java application should be able to run on whether it's Intel or Raspberry Pi, right? Because you're running on top of the JVM anyway. So it's the same concept applies. As far as installation is concerned, this is probably very straightforward, you guys. Whether you guys are interested in hearing a little more detail, I'm not going to spend too much time on this because probably not much into Edison either, yeah? You guys are more into ARM processor, correct? Okay. So as far as Intel goes, you get the board, the breakout boards, and the processor, and USB cable, that's all you need. And everything else beyond that in terms of software is easily accessible. You just Google the Intel Edison, and Intel actually provides pretty decent steps to how to actually get started. So, you know, for you to be able to cover larger market, you ought to definitely obviously run on ARM for sure, but Intel obviously is trying to expand their market share. It wouldn't hurt for you to guys have a prototype built on Intel Edison as well, right? So having said that, you know, once you be able to run it on Intel Edison, you could develop the same application across the board. So whichever you start, whether it's Edison or Raspberry Pi, end result will be pretty much the same, right? So with the Edison, you just need to update your, the image on your disk. There's the links there. I think everyone gets the copy of the slice, so you know I won't spend too much time how you do this. And then once you have it, you open one of the GUIs for Intel flashing tool and download the binary and just flash it. And then you just connect your terminal. Right? If you're using Mac, in my case, you know, you just connect to your terminal and find out which port that it's connected to. Then you just log on, and then you basically configure Wi-Fi. And then, once you have that, then you're ready to install your JVM. So, for the JVM for Intel Edison, you could download it from our website. Go to azul.com, Zulu-Embedded, and you'll see a download for Linux, x86, and there's another binary for Windows 10 IoT. So once you download them and unzip it or untar on your device, whether it's a Raspberry Pi or Intel Edison, only thing you need to do is basically set your path and you're ready to go. All right? Pretty simple stuff, yeah? Any questions so far? You guys all good? And then to actually develop an application, again, this is probably, you know, Eclipse Kura 101. You've probably seen this already. I mean, have you guys worked with Kura, Eclipse Kura already? You haven't yet? Not yet? You guys have a pretty good understanding of what Kura does, what OSGi and all that? Okay. So if you are, then, you know, I won't spend much time on it either. It's OSGi, right? It's open source OSGi. I don't know if you know the history. This is started from Eurotech guys when they built their ESF, and they actually open sourced it. Doesn't matter if it's Eclipse Kura, it could be Eclipse Equinox or any other open source OSGis that's out there. You could install it on top of our JVM. So in this case, for this example, since we were in EclipseCon, you know, we actually downloaded the Eclipse Kura, and Eclipse Kura had a very decent documentation where you could actually follow the steps after you download. It's a matter of basically installing it with their installation script, and it would do all the hard work for you. And once you have it installed, either your Intel Edison or Raspberry Pi, you're pretty much ready to go with your Eclipse IDE. So once you have it installed, it's a matter of firing up your IDE, your Eclipse, and start writing your Java app. There's a very good tutorial on Kura. In this example, I'm basically screen capture the Hello OSGi that you could actually mimic exactly what Kura people are asking, kind of suggesting you to do as a sample application, and then be able to deploy it directly on either Raspberry Pi or Edison. And there's one plugin. The one thing that kind of gets tricky is just the plugin that you need to install on your IDE. There's mTools plugin that you ought to have it on your Eclipse IDE. Let me just show you what that is. Are you guys familiar with that step, by any chance? So the reason why OSGi is very much relevant is because the older gateway devices, right? There's a home gateway initiative where OSGi is the standard. So if you are looking to develop an application that uses gateway type of devices, OSGi is something that everyone's expected to use, right? So being able to deploy an application through OSGi on your desktop, whether it's Raspberry Pi, Intel Edison, will give you good starting point if you ever need to develop an application for any type of gateway device that's based on standard. You guys aware of that, right? Okay. So in terms of the actual sample application, so we built a couple of demos. We were actually at the Java One last week. Any of you guys were at Java One by any chance last week? No, you didn't get to go. Okay, so what we did, that's something that maybe you guys know this already too, is we used device I/O APIs. So I don't know if you guys were aware of this, but if you want to develop a Java app that actually talks to a device to control something, to control the pins, input and output pins, so you could actually turn the motors, turn the LEDs on, or communicate something to a device, you need to have some sort of way to do it. And before device I/O became available, it wasn't possible to do it in Java. You just have to do everything on native C, right? But now you can. There's a, I don't know if you guys have you guys used device I/O API? Yeah. No? So it is OpenJDK project that's been out there for a while. Again, it's been sort of the hibernation because Oracle Sun kind of dropped the ball, right? So we start out as a Java ME kind of thing, and there's some effort to make that available on Java SE. So there is a port of device I/O for Raspberry Pi. So if you're using Pi, you could get the download directly from OpenJDK and be able to actually use it to do GPIO, I2C, serial, and even UART. So there's a couple of APIs out there that you could use right now to use it on your Raspberry Pi. So like the demos that I'm showing you, like this one actually uses GPIO. By the way, if you want to see the real one, we have it on our booth over there. You could actually control it. You could make it move, run. We call it Duke Mobile. So it's based on Windows IoT Core as an operating system. The concept here is really, it doesn't matter which OS you're running, right? If you're a Java developer, you ought to be able to deploy application on any type of environment, whether it's Linux, Windows, or even Mac. In this case, we did it on Windows because Microsoft said, yeah, it would be cool if we become part of this whole open source community for the IoT space. So yeah, we could work with that. So we port our JVM to Windows 10 IoT, and you could actually download that exact VM, which is based on Java 8 Compact Profile 1. So you pretty much did everything except the swing AWT. So in this one, we actually wrote a device I/O for Windows. So we took the device I/O for Linux, that's meant for Raspberry Pi. We ported over to Windows, and we'll post that sample code and API in a couple of weeks. We just have to clean up our code so it's clean, if you will, so we don't get into any type of licensing issues, whatever. But we'll post that code and have samples available on GitHub, so you guys could actually try it out if you're interested ever doing something like this on Windows IoT. Most likely you guys probably do it on Linux, but anyway, the same difference. There's already code for Raspberry Pi. If you want to use Pi, you could do it right now. If you want to do it on Windows, we'll share the code and APIs that runs on Windows shortly, so you could actually do it yourself. But the net of it is, you could actually control the motors, right, through the general purpose I/O pins on the device, and make it actually run. Same thing we've done for the controlling the LEDs. It's just a matter of toggling the pins on and off, on and off. So you could actually control that. And we're communicating wirelessly, so we have the sort of controller running on separate board. So we're actually using, I don't know if you heard about it, there's another board called Mino board, Max. It's another Intel x86 based developer board, but it's a 64-bit. Edison being 32, this one is 64-bit. But at the end, I mean, it's running 32-bit code anyway, so it's, you know, Windows IoT Core that we were running is 32-bit, so it didn't really matter. You could just as well use the Edison or Pi. But in any case, you know, the thing is, you can actually build something that actually have access to pins on the board directly. Something very similar. This one is, again, using one of the device I/O, I2C. Have you guys used anything? You probably may have used it for C application, integrated communications. For this one, you know, it's just basically communicating through the sensor, which is temperature and humidity sensor, displaying the output on a console. But same concept, you know, this one runs Linux, Yocto Linux, and basically communicating through the I2C. So, you know, we can share some samples. This is just some code snippet, but again, you know, let me know, and we could share the full source code for all these demos. You know, basically using the device I/O APIs and toggling the pins. That's all you need to do. And same thing for I2C. Just importing those library for device I/O, and then setting the bits. And then there's another demo that we actually are showing over there. What we call what do you call the industrial IoT in a box, if you will. Maybe it's an overloaded term, but at the end of the day, you know, this IoT has to sort of be practical, and you know it's being used in real life, then you know it's actually doing something. So we actually have been working with some of the actual system integrators out there who are actually developing real life solutions. So for example, this company that we work with, OSGi, it's a, gosh, horrible to name, open source something, I'm sorry, forgive me, but anyway, there's a group of companies out there that are based on building solutions based on open source tools. So what they've done is they actually built a prototype, actual industrial IoT use case where one of their customer is a large gasoline company, if you will, like ExxonMobil, right? So one of the things they wanted to do was to be able to monitor all the gas stations and individual gas pumps. And they have placed a sensor in each gas pump where it actually reads the performance of each gas pump, whether it's actually operational or it's actually low on the fuel in their tank underneath, or if it's malfunctioning, passing this information about the particular error that is generated by the pump. And then it aggregates through a gateway in each station, because you know each gas station would have maybe half a dozen gas pumps, and then it gets sent to the back end, one of their data centers. And all those information are streamed in near real time. And in this case, what you see here is sort of the Java app running on sort of the gateway type of device, whether Raspberry Pi. In this case, they're using Intel-based gateway, and then it's streaming data through MQTT. So in this demo is exactly sort of what sort of you would expect to have it in that industrial use case, where you have a Eclipse Kura, right, MQTT publisher and subscriber, sending through the message through the broker, the Mosquito project, right? We're using what's available openly, and then that information gets passed on to the backend. In this case, for simplicity, we've created a Netty web server, basically passing the information through the WebSocket, and then visualize it through the simple JavaScript UI on the screen. So this thing is actually simulated, if you will, or actually running on the small Intel Edison box. And if you had a chance to come to our booth, you could actually see that box with like half a dozen different sensors connected to it, and executing this application, including other open source components like Eclipse Kura and Mosquito and Netty, and showing the actual real life, you know, data stream on the screen. So again, you know, very simple to do. It's not as complex as you would think it is, but you know, something you could actually do today using available open source components and write an application that you could actually deploy in real life. Okay. So I think I'm running out of time. So at this point, I guess I can take some questions. Does that all make sense to you guys? Was it helpful? Was it too high level, or because I wasn't quite sure if you guys want to actually see more of the sample code, or if you want to see how to develop certain use cases like what we talked about. But in any case, drop me a line. This is my email address. I'll point you to where you could get more information, or I'd be more than happy to share the actual sample sources that we used to build some of those demos we just talked about, including the ones that actually uses Eclipse Paho and Mosquito for passing data through MQTT. Or, I'm sorry, this slide seems to be moving by itself. Anything else that you may have some questions on, I'll be more than happy to share. And then, I would love to hear what you guys are doing, so we could actually kind of help the community grow a little bit better. Because, my personal view is, because there's some sort of lack of drivers and initiatives in the IoT community based on Java, I think we're lagging behind compared to other platforms like Android. So we're hoping to kind of make that moving again. Another things that we're trying to do on our roadmap is to build some additional capabilities on baseline Java. Simple things like Wi-Fi, right? Right now, if you want to do Wi-Fi on Java, you can't really, right? Because there's no API for doing Wi-Fi or locations on Java SE, right? So you have to either rely on, custom code based on C through JNI, or use something like OSGi, which does provide some of those capability. But if you want to truly build Java-based solutions based on Java SE that anyone could actually develop on, you need some additional APIs, and that's what we're planning to do. So you could actually do Java-based application purely, right, based on what's available as a standard APIs. So that's sort of the things on the horizon for us, providing more capabilities on baseline Java platform where a developer could actually use on their IDs to build an application. Yep.
I have a question on memory management.
Yep.
You have mentioned that the business level ZIM-GVM provides no standard word GC collection. Is there a similar or analogous feature for the Zulu?
Not yet. Actually,